All right, so last time we learned that not all weak acids are the same, right? They can have varying levels of strength. And so the pH of a weak acid solution is going to depend on both the strength and the amount of acid added. So I'll just show you kind of generally how these problems go, then we'll go through an example. So just some things to remember. Remember that pH is equal to the negative log of the H plus, and then these are all basically rice table problems. So you want to start off with your rice. With acids, you don't really have to include the water. It's kind of just implied. So you can just say HA dissociates into A plus, or whoops, H plus, and then A minus. And then you see right there is your value of H plus. And then you'll get some kind of number for an initial strength, right? And then these will be approximately 0 because we're going to assume that the auto ionization of water is negligible. And then this will kind of be like minus X, and then some number minus X, X, and then X. And then when we're talking about the strength of the acid, that's what we're talking about here is the Ka. Right, and then remember that the pKa is equal to the negative log of the Ka, so you should be able to interchange between the two. And so then after that, you would write, Ka is equal to H plus times the conjugate base over HA, and then plug in some numbers, do some math, depending on what the problem is exactly asking you for. So let's take a look at a pretty simple example. So this one asks what is or it tells you to find the pH of a 0.200 molar HNO2 solution. And then it tells you that the Ka here is equal to 4.6 times 10 to the negative 4. Right? And so now it wants us to find the pH. We've got the concentration. We've got the strength. So next thing we're thinking about is rice table. So in terms of the rice table, we have an acid. So we have HNO2. It's an acid, so it's going to donate its H plus. So we'll have H plus plus NO2 minus. This is nitrous acid, turning into an acid nitrite. Anyways, the initial concentration we are given as 0.2 molar, so we simply plug this in. We assume that we initially have 0 H plus. That's not totally true, but we're assuming that the H plus from the auto ionization of water is negligible. The concentration of NO2 is 0, and then we're going to dissolve some of our acids, so it's going to dissociate. So we'll have negative X, and then these two will be plus X. And then we have 0.200 minus X, X, and X. Next thing we want to do is write out our Ka, our equation for our Ka. And remember, it's products over reactants. So in this case, it's H plus NO2 minus over HNO2. Then we'll simply plug these numbers into here. So we'll take this guy, plug it into there, take this X, plug it into there, take this X, plug it into there. And then we have kind of a situation where we have X squared over 0.200 minus X. And then we're going to use our assumption here. We're going to say that K is small. In this course, you'll almost always be able to use the assumption. So we'll say K small. So X is small. And so 0.2 minus X is approximately 0.2, so it's not going to make that big of a difference. So we say now our Ka is X squared over 0.200. And then we also know that our Ka is 4.6 times 10 to the negative 4, so we can plug that into there. And then we simply want to solve for X. So you're going to multiply both sides by 2. And then take the square root. And so when you do that, you should end up with 9.6 times 10 to the negative 3. And then you can check your approximation as well. So X over 0.2, is that within 5%? We have 9.2 times 10 to the negative 3 over 0.2 times 100%, and we get 4.8%. So our assumption is valid. It's within 5%. And so we are okay to go ahead and use this assumption. And so remember here, if we go back up to our table, our concentration of H plus is equal to X. So we can say this is also equal to the concentration of H plus. And then what we want to find is the pH. And so we know the pH is equal to the negative log of the concentration of the H plus. And so we take this concentration of this H plus, we plug it in there, do the math, and you get 2.02, right? And that makes sense. The solution is acidic, which makes sense because we added an acid. And this stuff is all just practice with the rice tables.